Hello everyone, this is Project 1, Material Classification and Selections. In this project we are going to find out how to build a bicycle frame using different material. For example, we are focusing on advantages and limitations of the material, the availability in different countries, and describing the material type and specification. For material classification, we can use a composite material made of graphene and epoxy resin. The epoxy resin is not going to be a single layer, but multiple flakes dispersed in the epoxy matrix. And for this reason, the graphene is going to be just 1% of the total weight. In this slide, we can see that the material with the best properties is the carbon fiber epoxy with graphene nanoparticles that has the best properties of all the other material compounds. The only drawback is that we can see on the last graph that has the decreased amount of hardness, but for the rest is still the best choice. For material classification, we can start from the epoxy resin that is a ring made of one atom of oxygen and two atoms of carbons. Is a three-dimensional cross-linked structure made of pre-polymers and polymers, and usually they tend to have a lot of cracks on it. So for this reason, we combine the epoxy resin with graphene, that is a non-metal, and it always referred as a quasi-metal because they have unique properties. Graphene is a 2D material with one atom thick and have a 2p electrons on top of it that they are allowing to have a efficient conduction of electricity. For advantages and limitation of this material, we can see that have a 70% internal shear strength, have a 50% increase in fracture toughness, and 20% less in material weight. The drawback is have a long production time, is really expensive, and is not environmentally friendly. Graphene composites are currently under development, and they are not made for mass production. For this reason, they are mainly produced in a first world country, but at this moment, like some developing countries, for example, like China, are leading the research on the graphene application. Even though there are many publications and research about graphene, there is still a limited practical use. For this reason, we still need to find new opportunities, and artificial intelligence can be the right tool to speed up the discoveries of new material and reducing the cost of research, giving the opportunities that artificial intelligence can forecast the inner properties of new material.
Thanks, Diego. This section examines the viability of bamboo as an eco-friendly material suitable for a bicycle frame, through the criteria of its material properties, how these are suitable/unsuitable, its availability, and its cost. Bamboo is a natural fiber, a composite consisting of cellulose microfibrils in a matrix of lignin and hemicellulose. Its particularly high lignin content, the macromolecule responsible for stiffness, compared with most other natural fibers, provide its desirable structural properties. So bamboo sits between spruce and steel in tensile bend and shear strength. It has a high flexural ductility and deteriorates naturally, mostly through fungal decomposition. Here's an overview of its structure. You can see this diagram shows the structure from the millimeter down to the unit cell. Note in particular how you can see the difference between the ordered regions of microfibrils, which are crystalline, and the unordered amorphous regions. Cost and availability. So due to its robustness and fast growth, bamboo is among the cheapest and most readily available structural materials in the equatorial regions. Depending on the required diameter, level of processing, and scale of production, bamboo ranges from around 0 to 30 AUD per kilogram. Here's a map of global bamboo distribution. Note the belt around the equatorial regions. Advantages and limitations. It has a high availability in equatorial regions. It's inexpensive, fast-growing, easily processable, high strength to weight, and very environmentally friendly. Its bamboo farming can even be carbon positive. In limitations, it's not that available outside of those warmer, wetter equatorial regions. It requires chemical treatment for durability, especially against fungal decomposition. Its flexibility is not desirable in all applications, like some high-performance street bicycles. and it has a low fracture toughness, so if it does develop cracks, they will likely develop into larger failures. So the verdict and point of view. So due to its suitable properties, performance, structure, and processing requirements, bamboo is a viable material to serve as a bicycle frame. Its inexpensive and readily available nature make it perfect for developing equatorial regions. It acts as a carbon sink during its growth, and with suitable farming practices and minimal processing, it's a plausibly carbon negative activity. When researching this material, it seemed to fit the criteria impressively well, and I was sure there had to be bamboo framed bikes already. I wasn't disappointed when I found a UN-backed initiative in Ghana which successfully employed locals to manufacture bamboo framed bikes. It's a good role model for what low-cost bamboo framed bikes might look like. These examples feature bamboo tubing as the frame with a composite of hemp, teak, and resin at the joints. The only processing required was being cut to size, dried out, and treated against fungi and water. Thank you.
The final material that we discuss will be aluminium and its implications for a bike frame. As for the classification of the material, the properties of the material will be initially considered. The value of bonding energy will give a direct correlation to the melting temperature and give it easy classification of the material, as seen in this graph here. As in this case, aluminium has a bonding energy of around 133 gigajoules per mole, which suggests the material has a relatively high melting temperature. As for the elastic modulus of aluminium, has a value around 70 gigapascals, which suggests the material is relatively strong and stiff, however, still retains some sort of ductility. Knowing this information now, we can come to the conclusion that aluminium has a bonding energy. Aluminium can be considered a metal, as metals must have a bonding energy between 68 to 850 gigajoules per mole, as metals have high melting temperatures. As for the elastic modulus, it's just the material has the same engineering properties as metals. However, it has a lower elastic modulus, which suggests compared to something like steel, which suggests materials more ductile. As for the advantages of using aluminium as a bike frame, aluminium is less dense than most other metals due to it, as it is much higher in the periodic table, as metals lower on the table have a higher atomic weight and would be more denser in nature. This will allow rise to be more nimbler and more mobile. Aluminium's ability to resist corrosion and rust has great relationship with oxygen, as can be seen in this diagram up here, will increase the lifespan of it. As for the limitation of using aluminium, aluminium has no endurance limit nor resilience, as can be seen in this graph here, in comparison to something like steel, which means the metal tends to fatigue quicker than most other metals, as the stress load does not have to reach the upper yield limit. And in this case, aluminium frames are expected to only last up to 5 years, and could fail unpredictably at any time and could harm the user as well. As for the availability of aluminium in both first world and developing countries, the metal is used widely in developing countries due to its low cost. It's a very vital essential material. As can be seen in this graph here, it shows that aluminium is both manufactured in both developing and developing countries due to its low cost and it's essential material. However, issues of fatigue would pose difficulties in developing countries, as aluminium is rather hard to repair due to its highly effective heat conducting abilities. Overall, aluminium as a bike frame allows for much more nimbler riding experience for the rider due to its low density and lightweight. It would be a much cheaper alternative. However, this does not justify its ability to fatigue rather quickly due to its minimal resilience, as well as difficulties in repairing. In conclusion, I believe that the three materials chosen and the engineering properties have been fairly assessed for a bike frame. Thank you for listening to our presentation.